Hi guys, today we're going to take a look at 7.8, which is still solving trig equations, but some of these are going to look a little bit more advanced, maybe a little bit more challenging than the 7.7 material. So, for example, if you look at number 1, it says solving a trig equation in quadratic form. Well, if you look at what we've got here, I've got a sine squared, then I've got just a plain sine, and then I've got a constant. So this looks like a quadratic equation. And actually the way to solve this is to think in terms of a quadratic. Like I could think of this as 2x squared minus 3x plus 1 equals 0. I could think of that as just a normal quadratic equation. If this is what I had, I would factor that. I would factor it into two sets of parentheses. Factors of 2x squared are going to be 2x and x. That's the only way to factor that. The only way to factor a 1 is with a 1 and a 1. Now, that 1 and 1 could be positive or negative, and if you look at the middle here, I've got a negative 3. So my outer and my inner need to add up to be negative 3. So if I make both of these negative, think about that. You got to check. This would give me a negative 2x. This would give me a negative 1x, and those would add up to be negative 3x. So this would absolutely multiply to give me this. So this is the factored form. Okay? Now, what do we do next? We take both of these and we set them equal to 0. And then we just solve each of these individually. Well, that's the exact same thing we're going to do over here with this quadratic. We are going to factor this into two sets of parentheses. We're going to have 2 sine theta, and then we're going to have sine theta, just like our 2x and our 1x. We're going to factor 1 into minus 1 and minus 1. And then we're going to take these two factors and we're going to set them equal to 0 because, again, if two things are multiplying to equal 0, one of them has to be a 0. So either this is 0 or this is 0. And what we have are two little mini equations that we're going to solve just like we did the ones last week. Okay, so we're going to solve this. I'm going to go ahead and say sine theta will be equal to 1/2, if you'll allow me to do those two steps at once, which means theta is equal to the inverse sine of 1/2, which means this is going to be an angle that's in quadrant 1 or 2 and has a sine value of 1/2. So look at the charts that we had the other day. We're just going to look at our chart. We're going to see sine of 1/2, the angle pi over 6 is the angle in quadrant 1, and then 5 pi over 6 would be the angle in quadrant 2. So theta could equal pi over 6 or 5 pi over 6. But we also have this second equation that also could work. So sine theta equals 1. Theta equals the inverse sine of 1. And again, we're going to look at our chart. So if you need the chart from the other day handy, you'll see sine 1, that's going to be pi over 2. And only pi over 2. 3 pi over 2 has a sine value of negative 1. So positive 1, it's only pi over 2. So theta could equal pi over 2. And these are all the solutions to this equation. All three of these angles would work. All right. Example 2. So, if you take a look right here, I've got 3 cosine plus 3 equals 2 sine squared theta. So there's a problem here. I've got different variables. You know, imagine this is an x and this is a y. You can't solve an equation that's got two different variables. However, there are some little switches that we can use with trig equations. So if you remember, sine squared, I'm going to go over here to the side. Sine squared is equal to 1 minus cosine squared, which means I can replace this with that expression. If I did that, I'd still have 3 cosine theta plus 3 on this side. Instead of 2 times the sine squared theta, I would have 2 times this entire expression. So notice I'm putting parentheses here so I don't forget that everything's being multiplied. 1 minus cosine squared. And now I have an equation that only involves cosine, so I can solve it. 3 cosine theta plus 3. If I distribute this to open up the parentheses, I'm going to get 2 minus 2 cosine squared theta. Whenever you're solving a quadratic, you want to move everything to one side, and you also want your squared term to be positive. So I'm going to move everything to the left. That's going to give me 2 cosine squared theta. Then it's going to give me plus 3 cosine theta. Now I've got a plus 3, but I've also got to move this 2 over. I've got to subtract him over, so that's going to be plus 1. And now I've got a quadratic. I can factor this. Again, if factoring with the word cosine looks a little weird, you can always go off to the side and rewrite that as 2x squared plus 3x plus 1, and think of it in terms of, just x's, and then come back over and rewrite this. But these numbers are pretty small. Excuse me, that should not be a squared anymore. So I've got 2 cosine and cosine. That's how you're going to factor 2 cosine squared. I've got a plus 1 here, so again, that's only going to factor into 1 and 1. And then my only determination now is whether these should both be positive or both be negative. But again, that middle number is a plus 3. So if I make this a plus 1 and make that a plus 1, if you check, your outer would be 2 cosine, your inner would be 1 cosine, and that adds up to 3 cosine. So now I've got these two equations, 2 cosine theta plus 1 and cosine theta plus 1. Both of these could equal 0. So I just need to solve these two little equations. This one's going to be, I guess I could have done these steps at once, but cosine theta, negative 1/2. So theta equals the inverse cosine of negative 1/2. So again, cosine is negative in quadrants 2 and 3. So when I look at my chart, I'm going to get the angles that are in quadrants 2 and 3 that have cosine values of 1/2. So that's going to be 2 pi over 3 and 4 pi over 3. And then I'm going to come over, I'm going to solve this one. So cosine theta equals negative 1. Theta is the inverse cosine of negative 1. So I'm going to look at my chart. I'm going to see that cosine is 1 at 0, but that's not what I want. I want negative 1. So that's going to be on the other side at pi. So these two angles work, and so does this. So there are 3 solutions to that equation. All right, next example. So if you take a look here, I've got cosine 2 theta plus 3 equals 5 cosine theta. Now, at first, it may appear like we've all got, the same common variables. We've got a cosine, we've got a cosine, but we don't. This 2 cosine, so the cosine of 2 theta, cosine of 2 theta, and then over here I've got the cosine of theta. Those are different, okay? They're not the same variable, so we need to manipulate this one a little bit. Well, this is a double angle, and this is a single angle. Now, if you think back to section 7.5, if you want to flip back in your notes, you can. Let me show you. So here's 7.5. We had these formulas for double angles. Now, there were 3 different cosine double angle formulas. One that involved cosine and sine, one that involved just sine, and one that involved just cosine. So if I use this formula, it's going to turn my double angle cosine into a single angle cosine. It's just that the cosine squared, but that's okay. That's just going to be a quadratic. So that's what we're going to do. Because we have a cosine over here, then we're going to turn this into 2 cosine squared theta minus 1, because that's the double angle formula for cosine. Now, nothing else has changed, so we're still going to have this plus 3. We're still going to have the 5 cosine theta. And now I can solve this. Now, remember, there were 3 different formulas. There was another one that only involved sine. So, like, if this would have been a sine over here, we still would have been okay. We could have taken the double angle, and we could have used the sine formula, the 1 minus 2 sine squared, and then we would have got a formula that only involved sine, and would have been just fine. So, this is now a quadratic. We're going to leave the cosine squared where it is. We're going to move the 5 cosine to the other side. And then I've got this minus 1 and plus 3. So I can combine those. That's going to give me a plus 2. And now I'm going to factor this. So factors, this is going to factor into 2 cosine theta and cosine theta. Factors of 2, this is going to be a 2 and a 1 in one of these. I just got to figure out which one goes where so that my outer and my inner add up to negative 5. Well, if I make this a 2 and make this a 1 and make both of them negative, watch. My outer, when I FOIL this, my outer would give me a negative 4. My inner would give me a negative 1, and negative 4 and negative 1 would add up to negative 5. So that's how that's going to factor. And again, at any point, you can just go off to the side and change those into x's, and you could solve by grouping, or just maybe just having the x's makes it look a little bit more normal to you. Okay? So I'm going to set both of these little equations equal to 0. This one is going to be, let's see, this will be positive 1/2. So theta is the inverse cosine of positive 1/2. So that'd be quadrants 1 and 4. That's where cosine is positive. So I'm going to look over at my chart. I'm going to see cosine 1/2, and I'm going to see pi over 3, and I'm also going to see 5 pi over 3. That's the one in quadrant 4. Then I'm going to solve this one. So cosine theta equals 2. Theta equals the inverse cosine of 2, and I'm going to look at my chart, and I am not going to see a 2. Okay, why? Well, because there's no such thing. Okay, there is no angle that has a cosine value of 2. Cosine only goes from positive 1 to negative 1. So for this, there's no such angle. There's no solution to this part of the equation. That's okay. We've still got these 2 solutions over here, so there are solutions. There's just only 2. All right, let's take a look at the next example here. Now, on this one, I've got 2 sine times cosine equals negative 1. Okay, let's see. Now, and you may have noticed on all of these examples, all we're wanting, so this little expression over here, is telling us we only want solutions between 0 and 2 pi, kind of like we did on day 2 of the notes. There are an infinite number of solutions to all of these equations, but we're only interested in the ones from 0 to 2 pi. Now, for this problem, this is going to be important that we think about this. Now, there is no way to turn sine into cosine. I've got 2 variables here. I can't turn sine into cosine. I can't turn cosine into sine. Okay, it's only sine squared and cosine squared that I can manipulate that way. But this one has another little interesting situation. This entire expression, 2 sine cosine, is a formula. This is the sine double angle formula. So I could take this entire expression and rewrite it as the sine of 2 theta equals negative 1. Now, there was a problem earlier where we turned a double angle into a single angle. We didn't want a double angle. But the problem with that one was we had two different variables. We had a double angle, and then we also had a single angle in the problem, and we couldn't solve it. This one we can solve. It's okay to have a double angle. We did those in 7.7. It's just that at some point we're going to have to divide everything by 2, and that's going to change our final answers, but there's nothing wrong with trying to solve a double angle if that's all you're dealing with. So for this one, I've got 2 theta equals the inverse sine of -1. I'm going to go to my chart, and I'm going to see that the angle that has a sine value of -1 is 3 pi over 2. And then, for the first time in all of these problems, I am going to write that plus 2 pi k. Now, why haven't I written it for the other ones? Because if I only want answers between 0 and 2 pi, and there's nothing that's affecting this 2 pi and changing it, adding 2 pi to any angle is always going to give us an answer that's too big, and we don't need it. But because there's a number in front of the theta, and because to solve for theta, I have to divide by that 2, and I have to divide everything by that 2, it's going to change this 2 theta. If I divide everything by 2, I'm going to get 3 pi over 4, and I'm going to get 1 pi k. So this is one of my angles, 3 pi over 4. If I add pi, so if I think of that as 4/4, if I add 4/4 to 3/4, I'm going to get 7/4. So I've got 3 pi over 4. I've got 7 pi over 4, which is less than 2 pi, so it's within the range of values that I want, so 7 pi over 4. But if you add another pi, you'll get 11 pi over 4, which is too big. So anytime and this is going to be true all the time, anytime your theta is being multiplied by something so that you have to divide, you always need to make sure that you add that 2 pi k to check to see if there's some more answers. You don't want to forget those. Okay? All right, last one. Now, for this one, I've got a tangent and I've got a cotangent. Now, I've got two different variables. Tangent and cotangent are related, though. I actually can rewrite cotangent in terms of tangent so that everything's the same. I can just rewrite cotangent as its reciprocal, and now I can solve this problem. So what am I going to do? I've got a proportion. I've got tangent over 1 equals 1 over tangent. I could cross multiply. I could multiply this direction and get tangent squared theta equals, multiply this direction, that's just going to be 1. I could then take the square root of both sides, which is going to be tangent theta equals, well, the square root of 1 is 1, but it's positive and -1, and that is a common mistake that you're going to make. You're going to take the square root, and you're going to forget the plus or the minus. So now, theta is the inverse tangent of positive and -1. So I'm going to go to my chart, but when I do, so remember, when you go to your chart, there's tangent, there's 1. I want all 4 of these angles. I want the angles where tangent is positive, like pi over 4 and 5 pi over 4, but I also want the two that have -1 as a tangent value, so 3 pi over 4 and 7 pi over 4. So this one actually has 4 answers. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And those are the solutions to that.